good morning, everyone. Welcome to Micro-Resiliency in Action, Fortifying Critical Infrastructure. My name is Ben Lawless. I am a client account manager for Pond & Company, and shameless plug for Pond & Company, we are a titanium sponsor, and you can come see us at our booth. Today, our speaker is Pat Hogan. He's the Vice President for Conti Federal Services. So as always, little housekeeping notes. Please take note of the exits. Silence your mobile devices unless you want to be ruthlessly mocked when it goes off in the middle of the presentation, and we will rate your ringtone. The presentations and audio recordings will be available on this SAME website, and you can download your PDHs after the session, so just remember to do that. As always, thank you to our sponsors for this session. Without the sponsors, we couldn't do this. And so, again, I'm Ben Lawless. I'm the client account manager for Pond & Company, and some fun things about me is I'm a lifelong Washington Commanders fan, and that will become relevant in a moment. But you don't really need to be a sports enthusiast to understand my pain for the last 25 years. And so we got a new owner, we got a new coach, we got a new quarterback, and we're getting a new stadium, and that's going to bring a lot of business opportunities to the Washington, D.C. area. I'm a BMW enthusiast, and my wife sometimes says that our house looks like a used car parking lot, and I own that, and I'm trying to keep that down. I am a dog parent. We have 2 dogs. Sometimes I'm pretty sure that my 2 dogs are a lot more work than my 3 children were, but that's another story. And my wife and I are Airbnb hosts, so if you want to know anything about short-term rentals, see me after the presentation. Our speaker today is Pat Hogan. He's the Vice President of Conti Federal Services, and here's where it gets sort of funny. He's a New Jersey Devils and New York Giants season ticket holder, and as a Commanders fan, I have a little problem with that because I do not like the New York Giants. I don't like Philadelphia even more, but Giants aren't very good either now. Ice hockey and Jersey Shore family, and this is sort of interesting, 80s hair band live fan. I understand that. Obviously, that was in your younger days, or is that still something you're doing today?
Last week.
Oh, there you go. All good. And so his hobbies include building, golf, tennis, pickleball, and hiking. So before I turn it over, let me give you a little introduction to some of the things I see. So I managed Air National Guard design and construction for a lot of years, and obviously the whole theme for this JETC event is resiliency. And as federal government employees and federal contractors, we spend a lot of money doing resiliency plans. We think big. We think, oh, we got to make the whole installation resilient. This is a very interesting case study in bringing that resiliency down to the actual doable level. And so with that introduction, I'll hand it over to Pat, and I will get out of the way.
Okay. Thanks, Ben.
Sure.
We are going to back up one slide, though, because we're not going to let that Washington thing go here. Just as a reminder, one of the Giants Super Bowls, one of the 4, we did beat Washington 3 times in the same year. So let's not forget that. Also, a little fun thing this year. It's called the 80s hair band. From 1980 to 89 was a very unique, crazy band, hair bands they call them, and my wife and my college buddies, we still do that. Matter of fact, there's one in Ocean City, Maryland this weekend, so it's a lot of fun. Also, as I get older here, I've kind of switched over to pickleball because of my knees, but trying to do as much as I can. So a little bit about myself. I am in construction. We are a construction company. Okay, I am a civil engineer at a University of Delaware, and I've been with this company 33 years, since 1992. And I get a lot of questions, how can you stay at one company that long? And I got two very simple things I'd like to share. The first one is, it's a privately owned, family-owned company, and doing the right thing and the missions is all that matters. Every day we do the right thing. Okay, second thing to me is it's got to be fun. If your day isn't fun and all the teams and collaboration make it fun, when we do collaborate, we make it fun. All the stakeholders, all our trade partners, it's a fun atmosphere. All right, so back to micro-resiliency. As Ben mentioned, there's a lot of planning going on, big. We worked on the levees in 2005 for Katrina, billions, stuff like that. And sometimes we plan too much and they become too expensive and we don't do them. So we're kind of bringing up an example here of specific to an asset, a very critical asset. And this is a hospital in Jersey City, New Jersey. In 2012, those of you who don't know, New Jersey experienced they call it Superstorm Sandy. It was a collision of a northeaster and another storm from the west, and they collided over New Jersey. And New Jersey experienced surges that were never seen before, like almost 500-year flood levels. And the hospital, this is the Hudson River. Manhattan's over here to the right. So this entire area up to this highway that goes into the Lincoln Tunnel had 10 to 14 feet of water. And these places got absolutely wiped out. And this medical center, Jersey City Medical Center, had all their technology equipment on floor one, multi-million-dollar equipment on floor one that all got wiped out, and it shut the place down. And during an event, you need to get to the hospitals, and it was a real complete shutdown. So that's what we're going to kind of focus on is this critical facility and how we can harden it or make it resilient. Okay. So the threat, as we all know, we're experiencing unheard of climate changes. Sea levels are rising. I just mentioned the superstorm that this state has never experienced. I mentioned already, sometimes we plan, we say, okay, we have to protect the state or the city or very large-scale things, and it's just too costly, too disruptive. So we're going to talk about a little micro-resiliency here, which offers a more targeted, very efficient focus on this. It is unique design. I'm going to go over some of the design in a couple minutes, but it's very site-specific, right? It's an urban area. There's many things underneath the ground. This is a 100-year-old city. A lot of unknowns. And it does take a complete, what we call overhaul of the area. I do like to start with a little flavor of dollars, because sometimes we get billions and millions, and this is quite small. And so the funding came from a FEMA grant. So the hospital applied for a FEMA grant, which was granted, and the construction portion of it was $36.5 million. And I gave a little breakdown of the SOV just to give a flavor of what we're talking about. Almost $8 million of concrete combined with almost $6 million of flex wall devices. So in the big picture, it's not a ton of money. It's very focused on this facility. I'm going to mention a little bit about how we're able to do it. We were able to self-perform most of the work. And why that's high value is you have complete control over the daily operations, okay? Sometimes when there's so much change and you have other trades, other partners, it takes them a little longer to adjust to such an extreme change underground. But we were able to do most of it self-perform and change with it. Okay, so the objective was to protect the hospital without impeding daily operations, and this hospital is absolutely crazy. Okay, the amount of volume of emergencies they have. I will share a fun fact. One of our first days there, they were cutting the ribbon of an emergency department they had just added to this facility. And there was like ambulance flying in during the presentation of the ribbon cutting with all the executives there, and nobody knew what was going on. And this was our first day there, and we're like, oh my gosh, what's going on? And a bunch of cars just threw out a bunch of people that got shot. We're like, oh, what is this? Like, what is going on here? And what happened was there was like a gang shooting or something in like 10 towns over. And during the ceremony, they kicked all these people out, you know, on the thing, and and everybody starts scrambling to help them. So that really set the mindset with, hey, this is a very important, critical infrastructure for this area. So that kind of set the tone for us on this is going to be a tough one. So there is 500 feet of what we call deployable barrier wall. You're going to see pictures of it. And there is 1,000 feet of concrete thick walls. It looks like a dungeon, a castle. Okay, so it is a mix of deployable and what I call concrete wall protection. There are 15 windows in the walls, and this is for the executive offices on the first floor so that they could see outside so they're not looking at a fortress. There are 8 flood doors, same concept, to get in and out of the concrete flood doors, and there are 7 roll-down doors for their loading dock area. And this is very critical to this structure because they're roll-down doors. This is where they bring the medicines in 24/7. This is where the morgue is. The bodies go in and out. It's a crazy loading dock for a urban environment hospital. We did design 2 pump stations to deal with moving heavy volumes of water around the facility. That was a last-minute add. They are quite large. So now I'm going to get into the uniqueness of it. So originally, it was designed with micropiles. I'm going to tell you who the players are here in a second. All right, just so you know the players, I'll back up. So this is where the money came from. This is the end user, RWJ Barnabas, which is the big company of the medical center. We are the construction company. Arcadis was the designer, and Blanchard was the construction manager. Now, there were 3 separate contracts with the owner, which is kind of unique, right? And the reason I'm telling you that is we report to them, they report to them, and they report to them. So it was very important to have collaboration because they don't know construction. They're in the health world, right? And these people know construction, design, and construction. So we constantly had what we call Warrior Lean collaboration sessions with this group for the good of the mission, okay? And it was very critical that worked. So I'm going to back up a little bit. Back to the, so there were 326. Now, they were originally designed with micropiles, but I'm going to ask a question here. What's wrong with micropiles next to an active hospital? What would you think would be the problem with boom, 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 5 feet away from an active hospital with sensitive equipment? Yes. Vibration. Yep. Soil particle velocity vibration in the ground, right? So the micropile design in the beginning was, ain't happening. Okay, so we collaborated with the designer, And again, the uniqueness, we had to understand their loading of hydrostatic pressures of the water, which, by the way, was designed for 18 feet of water, which is quite high. So in understanding the criteria of the loads, of the static pressure of the water, plus the dynamic pressure, who would think what a dynamic load would be in an urban environment on a street? You got it. Cars, telephone poles, light poles, hitting the structure. So in collaborating with the designer and the loads, we came up with a drilled displacement pile, okay, which is basically, you drill down, auger cast is another word you basically drill down. You're only displacing the soil that's drilled. We had to treat it as contaminated because this is a contaminated site. And then you kind of start figuring out, okay, here's the bending moment capacity, here's the compression, tension, lateral, and you kind of start reverse engineering on what we need in this pile to resist these kinds of loads. And it wound up being, this took us about a week to figure out. It wound up being a 24-inch, because there is friction value on the pile combined with end bearing. So it is a dual capacity pile. So we wound up doing 24-inch diameter piles with a steel casing down the center of it, and that resisted the bending moment criteria. And then we put a number 8 grade bar down the center, and that would be for pullout. All right, so as you get uplift pressure from the floods, that was kind of the anchor. So when the group came up with this, and we were able to successfully do a test program. That's the first thing we do is a test program. And it worked. Everybody was high-fiving, okay? And then the best was yet to come is this method actually was $2.7 million less than doing it the traditional micro piles. They were quite excited about that, and we were able to generate a savings for them before we even started. So that's a good example of collaboration, understanding what you're doing. This is not a design-build job, right? This is a bid-build job. But it's very important that you work as a group and understand what's going on. All right, so some pictures here. To me, it looks like a big, hefty garbage bag that hangs on the post, and this is the back of it. Okay, so this is a street. So as the water comes up 14 feet, basically, this keeps it off the hospital. And the deployable portion, we're looking at the deployable portion, actually goes into a trench that's stored underground. And I'll go over that in a minute. Okay. Okay, here's a little cross-section of the trench that it gets put in. So here's the two scenarios. Concrete wall in front of the hospital, kind of ugly looking, right? Nobody wants to see that in an urban environment, so what do? Okay. And then here's the post that we just see that basically held up the hefty bags, if you want to call it. Okay, and as you can see here, very robust foundations with DDP. Another thing we had to fight, when you build an earth dam and they're scouring, when you have such hydrostatic pressure up above, the water wants to scour under. So we had to come up with, I call it a shear key, to prevent that. So that was a last minute add to the design, okay? Some other things we added, there's a admixture product to put in concrete that makes it more dense and what we call watertight. It does add about 15 or 20 bucks to the cost of the concrete. So this is a stainless steel basically trench that the flood device, when you let it down, gets put into. Okay. I've been talking a lot about, this is a Conti thing. We call this Warrior Lean. Works very well for us. It's a mission mindset, right? Collaborative strategy, getting together. You know, this is an infinity loop, right? Constantly understanding the mission, the need, everything that's going on. Pre-planning as a group. When everybody pre-plans, they're usually pretty good. Okay, and then making sure it gets done, executing it, and then saying, hey, after we execute it, did it work? What are some lessons learned? How can we get better? And then coming back and making sure it meets the expectations of the design, the mission, and all that stuff. Okay? Some challenges, as in any other project, when you're going into the earth and you don't know what's down there. Yes, we use GPR and we test pit, but we can only go so far. These are 40, 50 feet down into the earth. And we wound up, you know, back in the 1700s, we pulled up old foundations, we pulled up old fiber optics and stuff like that. Well, it wasn't fiber optics, some other type of conductor, but you constantly pulling up stuff out of the ground with the auger cast system. So that was a big challenge for us. All right, just a little layout of the facility, the urban environment here of this hospital. So one of the things we had to do is you can't, I mean, this hospital is 24/7 crazy. Okay, they only have two entrances. They got an entrance off the street, and they got here, this little horseshoe piece here is their main entrance, okay? So that's the two entrances that people can walk into, okay? Their ambulance department is over here. This is where all the ambulances come in, and this is their loading dock that I already talked about, where all the goods come in, and the morgue and all that stuff. This is their own internal power plant for electricity for the all the generators and natural gas utilities. So we had to come up with a 12-phase plan to keep this hospital open, okay? Now, whenever you start thinking about phases, it becomes more expensive, so how do you make it cost-effective? So again, we collaborated with city officials, because this is a main street that goes to the Hudson River. The Hudson River's this way. So this is a thoroughfare with a lot of traffic, a lot of buses, bike lanes, people walking, and craziness, okay? So we were able to, work with city officials and work with their traffic engineers. And don't forget, cities like this, they have 5K runs every weekend and all kinds of stuff going on. So we used to meet once a week with them and plan out when we did these phases here, 1, 2, 6, and 5. We did it at night, okay, and we just worked around them. So again, working with city officials and the public for the common good of a mission, okay. So also the ambulance area here, okay, always had to have access. So instead of building these in little pieces, we were able to kind of just reconstruct, new pavements and everywhere, and able to work with the hospital to always have an emergency door. They got those quick opening double doors. We bought like 5 of them. Kept moving them around for them so that every minute they had a emergency access. All right. So some lessons here in micro-resiliency, right, is, think small, act big, okay? You don't need a massive overhaul and a ton of money to save a city or save an area or save a state. or whatever, you can target major assets, critical assets, critical infrastructure pieces, okay? Every job is unique, right? Every state has a unique situation, different underground, situations, all right? And you have to engineer it to make it work, what I call native to that state, right? Every state has different soils and different things, so you have to smart engineer it that's native to that state, okay? Again, we did a 500, like sometimes you're thinking, is Superstorm Sandy ever gonna happen again? Probably not in our lifetime, okay? But as things change here with the climate, we did design it for a 500-year flood. So we are thinking ahead, and this hospital is now state-of-the-art for an urban area that they tout now that they're ready. They're ready for any major disaster in this area. This is what it looks like on the entrances. We did test with 14 feet of water. You can see in this picture, there's 14 feet of water on the other side and how it bows, okay? It gives a little bit. So this protects all the main entrances to the hospital. So there's two of these, one on each side of the hospital, okay? Some things we did, again, they're a hospital. They don't know construction. So we did a bunch of training of their maintenance people, their building maintenance people. We did video documentation because they have a lot of turnover. So this way, as the people change, they always have a video on how to deploy this stuff, how long it takes, and everything for them. We educated them on all the pieces. And they actually have a contract in place to maintenance once a year, because this stuff is sitting in a container or in the ground in those trenches I showed you. So they do have to be maintained once a year. There is a maintenance contract once a year, okay? All right, we talked about ugliness of a wall outside of a hospital. So we worked a bunch on aesthetics with the hospital mostly. They have an art department. So we came up with some grates. This is all now full of ivy growing up. So here you got the bike lane. That's Manhattan straight ahead there. So we were able to make it look not like a fortress, right? And now these spaces here, they put some artwork in. They let the locals do some artwork. So aesthetically, this looks really good right now. So we were able to aesthetically improve it, because the hospital was always worried about, we don't want to have, it's going to look like a castle inside of an ugly wall. So we're able to do that. Now the section the 500-foot section that holds what I call the hefty bags up. So these are columns, and we put a really nice marine paint on it that matched the color of the granite of the hospital, so they do blend in very nicely. And they're not so ugly, right? They kind of just look like almost decorative pieces outside the hospital. And as you can see here, here's the trench that the device is in, and that's a stainless steel. It lasts forever, okay? And if water gets in there, there is a drainage trench in there so that these always stay dry. So this is what it looks like with the devices not deployed. And this makes the hospital very functional. As you can see, this is we built a nice terrace for them outside the cafeteria that they come out in, and it was a very functional approach. Nothing changed for them. They were very happy. Okay, so this facility, the takeaway is they set the standard for healthcare resiliency in a disaster-prone area. This is Manhattan in the background. You can see how close it is to the Hudson. This is the emergency department they just put on. They added onto it. Now, our project started from this corner that way and this corner that way. They built the new hospital wing here resilient to 14-foot flood waters. So our project was from this corner all the way around it, all the way to that corner. Again, their takeaway was the collaborative planning, someone that knows construction, someone that knows design, someone that knows construction management, right? The application of our lean construction process, which was that infinity loop. You know, engaging the city in the mission. Right? As everybody knows, city people sometimes are a little rough. All right? They don't participate in everything. Sometimes they're not always cooperative. But when you continue with the mission, we constantly talked with them about the mission, right? Trying to do the right thing for the people. This facility needs to be open at all times and during all events. All right, so be part of the mission, and that kind of pumped them up to participate. Again, kind of what Ben started off with is, you know, this is a smaller version, a micro-resiliency approach. This is specifically a healthcare facility, but it could be any main infrastructure facility to serve, you know, the public during times of crisis. And that was a big takeaway for the whole community. I do want to mention one thing about FEMA projects. So back to the dollars. As you note here, we built it less than the grant, which is unheard of in a FEMA environment. So FEMA is actually going around using this project as an example of it can be done. It's not an open checkbook. Everybody thinks FEMA is an open checkbook, got to do whatever you got to do to harden the facility or whatever. But this is a case of, you know, complete collaboration and delivering the mission less than the grant. So they actually had told us at the ribbon cutting that this was the first FEMA project on the entire East Coast ever constructed less than their grant value. So it can be done. This is small potatoes, I know, with most of you guys are probably working with, but it's a very good example of micro-resiliency. You can focus on a critical infrastructure that you need to protect. So I think we are ready for questions.
Okay, let me go down to, again, there'll be a survey that you guys can fill out after this. And, you know, it's important that we hear from you about the presentation. So if you're going to ask questions, please come to the microphones because we do record these. And so when later on people can hear the questions. So I'll start us off with a question, Pat, and thank you for that presentation. You know, it's not often we get to see something constructed of this magnitude and this complexity. So a couple things that came to my mind is, how did you solve the staging area problem for this project in an urban environment around an active hospital?
So one thing, being a construction company, we don't know how hospitals work. So we were able to get all the divisions of the hospital. And a hospital has several divisions, you know, maintenance division, this division, that division. And we were able to get them all together to present to us on how does your hospital function? Like, let us know what happens with the morgue, how do the medicines get in, when do they come in, how do they come in? You know, really understanding the flow of their mission. And they actually drew pictures for us. They gave us diagrams, they helped us. So after we understood their need, right, then we're able to adapt okay, on how we can break the project into phases. The one screen showed, I think we had 12 or 14 phases, okay? And then they don't understand it, so we have to have sessions with them prior to going into that stage, okay? One of the things we ran into was when people want to get from A to B, they don't care there's a construction site there. They will walk right through the construction site. They don't want to listen for a detour sign. They just don't care. They'll actually step over the barriers to go that way. So one of the things we came up with was we added fence and that mesh, advertising mesh for the hospital, like when you see on construction sites, we're improving our hospital, thanks for being patient, all that kind of stuff. And that prevented the people from walking through the construction site. So it was a collaborative effort. Each time we encountered an obstacle, we would sit with them and say, how can we solve this? Right? We didn't want to throw darts at each other with, oh, the barrier's too low, you, Mr. Designer, didn't think of it. None of that happened, okay? It was very, how can we fix it? And that was the approach.
Okay. Kind of another question. It's kind of unheard of to hear a construction project coming in under budget. Unheard of. Now, you did get some savings from your pile foundation redesign. So what other things did you employ during this project to keep the cost in line?
So one thing we do is we have a risk matrix that we put on our construction trailer wall so the customers and designers see the risk. But we also have an opportunity board, okay? And we want to understand, do you really need this? Why did you design this? Why are we ripping out curb or parking lots over here? They just redid it 2 years ago. Why are we ripping it out? And stuff like that. So you generate, why do you need it? And they have to be blunt. Sometimes they come back and say, oh, we need it because of this. And that's it. Discussion over. But sometimes they do say, well, yeah, that was kind of a request that the hospital made in 2014. Well, 2014 was 10 years ago. Let's re-ask them. And things change. So we were able to create savings on stuff they really didn't need that was in our contract. But the only way you can do that is to keep picking at them. Like, why do you need this? Why do you need this? Why do you need this? So we did that. And as much as we saved them, we also said, guys, there's going to be a lot. Everybody knows there's extra work on construction projects. Everybody knows that. And we were working underground, and we hit a bunch of stuff that cost them. Okay? But the difference is the money they spent extra dealing with underground obstructions, and the water table was contaminated. That money was offset with what we saved them. So the net at the end of the project was less than the grant value. So that's a true collaborative approach. Pluses and minuses, right? Everything has pluses and minuses. It's important to balance it out. So that's how we create value.
Okay, thank you. We have a question over here.
Yes, what did you do about the water that, like say, landed on within the compound itself? I mean, like say for the contingency that the stormwater drainage system was blocked or something like that, or too inundated to also be able to, account for or to contain the excess water that was, coming into the compound itself. Of course, you don't want to have this retention wall built up around the compound and then it gets flooded internally, you understand?
Are you talking about stormwater or water table?
Yeah.
Stormwater?
Well, I guess it could be both, actually. I didn't think about, well, my question was for stormwater.
Yeah.
But I guess, yeah, like the water table could rise as well.
So stormwater, we actually had a drainage control plan to capture this before it got to the structures. So we were able to put in basically a gigantic trench drain to capture it. In one of my slides here, you see, oops, wrong way. Can you do it by hand?
Oh, sure. Which
Go
one?
down to the one of them has the cross section of both walls.
Is it this one?
It's not working.
Oh, yeah. We're working against each other.
Yeah.
Hang on. Which one you looking
It's
for?
not projecting though.
Oh.
Let's see.
Oh, yeah, you, oh, shoot. Technical problems.
Wait, here we go. There we go, I got it. Okay, so to answer your question, so see these trench drains that oh, you're over here, sorry. So here, all the surface water got collected in these trench drains that were diverted sideways, okay, and then dumped into the Hudson River, basically, through larger pipes, obviously. But that's the answer to, that's how we controlled keeping the water off the hospital and off the wall. Now, groundwater, a little more challenging, because when there is a surge on the Hudson, the groundwater does come up. I had mentioned we had put pump stations on. There's 2 big pump stations in here. They do kick on when the water table comes up to a certain height. We have a sensor on it, and the pump station, when it gets to a certain level, the groundwater, they kick on, and we built a discharge pipe out to the Hudson. Float switch, yeah. Sophisticated one, though. I found out the hard way, the cabling for the sophisticated switch was quite expensive and rare, but that's how you learn. So this place is dry. That's the 2 ways we did it. We did this to manage the surface water and the pump stations to manage the water table. All right?
Hey, just, can you say where you're from and who you are?
Yeah, my name is Andy Lynch. I'm from Chicago. Question on the electrical. Was the electrical and mechanical rooms, was that on the first floor? Did that have much damage? Did it fully need to be replaced? Or what did that, look like?
Yeah, so the mechanical room was on the first floor, and it got wiped out and completely redone. Not on this project, though. So the FEMA grant they got for this project was to harden the facilities,
Okay.
make it micro-resilient. So all the stuff that got damaged in the hospital were other contracts,
Okay.
other funding. But we did, all our power, there's a winch system that pulls the device up on
Okay.
it. That's all powered and
Okay.
mechanical. So we ran all our conduits into that
Okay.
room, and that's where it's controlled from.
Gotcha. Okay, thanks.
Hi, I'm Trevor Lamp, HDR. I love seeing this project. Actually, I was a long-term resident of Jersey City. I lived about 4 blocks away from the hospital on Bright Street from about 2008 to 2020. So I was there during Sandy. My daughter, who's our first child, was about 2 weeks old at the time when the storm hit. So it was quite a scene. So seeing this kind of progress and bounce back of the city is really fantastic. My question pertains to the work that Conti's doing. I love the idea of micro-resiliency. Like, what can we do? What is something that's not taking too big a bite, that is achievable? And wondering if you're seeing a significant uptick in that as construction contractors. If that's more of a theme, if there's other kind of instances that you're seeing piggybacking on this kind of experience, if that's an area of growth. Because you're right, sort of looking at comprehensive plans for a city or a state, becomes economically not achievable. But seeing projects like this is a really fantastic kind of case study of what we can do concretely and successfully.
So yeah, there's been an uptick, and in the health industry and military facilities with how can we protect some of our buildings that are critical. But what we are finding is there's 3 or 4 companies that make those devices, the manufacturers, and they're designers too. So they're out selling it, right? Typical, they're selling a product, but they're not bringing the constructability and the dollars to it, right? So we're trying to convince them, hey, come with us so we can give the holistic picture, okay? Not just how your devices are the best, right? We can bring, hey, in this environment, this is the kind of foundation you're going to need to withstand these pressures, and we can give a ballpark, a ROM, on that value. you know, because, you know, now we have the numbers, and we can actually give real numbers to it. So the obstacle for us right now is these 4, 5, or 6 companies are out selling the product, but not giving a holistic approach. So we are trying to get them, you know, around, say, let's go in as a holistic approach.
Right.
So,
Great.
did that answer it?
Yeah, thank you.
Yeah.
Okay, can I have the clicker? Pat? Sorry, I'm taking it away from you. If there are no more questions, remember to take the survey, please. And of course, advertisement for future SAMI events. And thank you, Pat, for an interesting story on a project that really has real world results. And thank you guys for attending. So